My name, as Marco said, is Daniil, and I work at the University of Potsdam. And I've been doing network analysis, I would say, since 2015, and specifically network analysis in the humanities, mostly in literature. And in 2017, we started this big project called Drakor.org, which I'm going to mention several times today, which is focused, or at least has been focused at the beginning, on the network analysis of dramatic texts. And we have thousands, literally thousands of networks representing drama in different languages, which we use as a model to study structural properties of drama and to study literary movements in general. And it's our basically one of our main models to study the composition of literary text. And we are still doing a lot of network analysis here in Potsdam, even if you just look at my room, and I'm now showing parts of the room where I'm sitting in, which is the room of Digital Humanities Network in Potsdam. You can see there are networks on the walls basically, so that already should tell you that we are still doing network analysis. So I'm saying all that so that you know why maybe you should trust me or give me a bit of credibility in matters of network analysis in humanities and specifically in literary studies. So let's start with the basics. The model we are talking about here is called a network or a graph. I will use these words interchangeably. And at its core, it's very similar, really. It's very simple, really. It's just some basically abstract objects, which we call nodes or vertices in this case, and some links which connect them, which we call edges or sometimes arcs. That's basically it. Very primitive, very abstract. So anything can be modeled like this. Islands with bridges, countries with trade between them, characters speaking to each other, people speaking to each other, anything basically, cities and flights between them, or transport routes. But this is exactly what gives the model its power, actually. So almost every object of research where we can formalize certain connections between certain objects, and you can imagine almost in any branch of science we can think of something like that, can be modeled as a graph. And originally this thing was this graph theory, this whole graph theory was suggested in early 18th century to solve a certain transportation problem, which is still a big area of application of networks. It was suggested by Swiss mathematician Leonhard Euler, whom many of you probably know, and maybe some of you even know which city was concerned in this transportation problem. Does anybody know? You can say it or write in the chat. The Latinized, you can call it Kaliningrad, yeah. Back then it was called Königsberg, yeah, so thank you, Ved, and thank you, Rita. So you're both right, yes, it was concerned with Kaliningrad, or Königsberg back then, which is here on this slide. It's the original writings by Euler, which is here called in its very beautified Latinized name, Regiomonte, which is literally Königsberg, regal mountain, basically. And so originally Euler created this simplistic model to solve this problem of the 7 bridges of Königsberg, which was a long-standing riddle in the city. So basically people were discussing if it was possible to cross all the 7 bridges of Königsberg over the river Pregel once without crossing any one of them twice. And basically Euler figured out that he doesn't need any information about what kind of bridges they are, what is on the banks of the river, what's on the island. All he needed to know is that there is this kind of points which are connected by bridges, so basically by arcs, by edges, and that's all he needed. So basically he abstractualized this whole rich topography of Königsberg. And abstractualized it to dots and edges. And using this simplified model, he actually showed mathematically it was indeed not possible to do that because this network had a certain properties. Basically, it is about the number of edges, the number of nodes which have odd number of edges. So if there is more than a certain number of those nodes, then this route is not possible. So this is how network theory was born. And it was widely applied to a wide range of systems of objects in the world. You can still use it to study a lot of transportation system, starting with railroads and electricity transportation, and ending with internet, of course, which is a network, as we know. But you can also study biological networks, biological systems which are connected, like protein-protein networks. And of course, you can study social systems. Yeah, I mean, that's where social network analysis comes in. And here's a brief example of my own social network. So it's a network which is centered on me and extracted from a certain social media platform which I use. And even by looking at this network layout, you can already say some things, right? So what could you say about me looking at this? Do you have any ideas? These are basically all the people who are befriended with me in a certain social network, and also the connections between each of them if they are friended. Yeah, 3 friend groups. Yeah, thank you, Marialine. That's true. So that's already something that you can see already from the very basic visualization of this network. You can see that there are 3 groups of people among my friends which are also very much connected between each other. And that's actually my school in the bottom, my bachelor's on the upper left, and my master's on the right. And you can also, how do I differentiate them myself? You can also see here one important parameter, basically a metadata parameter of each node. You can see that they're colored in 2 colors. What do you think that is? Uh, no, these are not different. Yeah, I mean, maybe. Yeah, male, female, of course. Yes, yes, that's also easy. So yes, these are males and females, which is the typical information which is available on social networks normally. So yeah, I mean, we don't go here into the complexities of gender, but yeah, most people just specify it if they're male or female. So, and I was actually studying my high school was actually a single-sex school. So in the bottom you see a predominantly male cluster, which is my school, and on the upper left you see my bachelor's, which was we had like 1 boy per 7 girls basically. So you can immediately see that this is my bachelor's, and of course this model does not stop there. It doesn't stop at the real, does not stop on being able to capture, social networks in reality. You can also capture social networks in non-real objects. For instance, fictional networks or historical networks, or like networks which don't exist anymore. You can still, or which never existed, you can still capture them as networks as long as you have an idea of how to formalize a connection and what is a node. So what is an object? What is a node in your network, and how do you establish a connection between them? And as I said, there are actually thousands of such fictional networks, specifically networks of plays, which is part of the project which I'm, responsible for, or like semi-responsible for, which is called record.org. I will mention it one or two times more, and it's part of CLS Infra project, which is basically the organizer of this workshop. So, obligatory native advertisement. Yeah. So, but okay, you can ask, okay, this is all, looks kind of nice and maybe interesting, but why is this model actually useful for us? Why is this useful as a research model, as a research proxy for some, objects that we are studying? Why would we want to convert something to a network? And one reason that I find very useful is network centralities. So one research method, let's say, which is available to you within the network theory is network centralities. So centralities are actually at the core quite intuitive. Again, if you look at this network, who would you say is the most central character here, or like most central node? Alexei, yeah, everybody is agreeing on it. Like, how do we know that? And how can we formalize that? Yeah, he's most connected. He's most connected. Yeah, you can just count the number of links. Exactly, exactly. And that's the basic, that's the simplest measure of centrality that you can imagine in a network. So you just basically put that into numbers. You count that Alexei has 5 connections, and all the rest, everybody else in that network have just 1. And this is called degree. This is the most basic centrality that you can ever imagine in your life, basically. And the standard way of visualizing that, at least like the way to which we are used in the network analysis, is through node size. So basically, we can make node size proportional to a certain centrality. In this case, the degree, which is basically number of connections. And here you can see the very typical visualizations. But this is not the only way to measure centralities. In complex networks, which are bigger, and more complicated than this one, you can have very different centralities reflecting different things. So in this case, for instance, we're looking at a different network, a bit more complicated. We also have Alexei here. And what distinguishes Alexei here is not the number of connections, right? If you count them here, you will see that he only has 3 connections here. But somehow we see that he's important as well. So if you count his degree here, he will not be the highest. There will be more people which have 4 connections, for instance. But you can see that he's somehow very important, right? So how would you formalize that? Yeah, he connects 3 different friend groups, or basically he's at the intersection. He is a very important intermediary. Yeah, if you remove him, the network will just disintegrate into 3 totally unconnected networks. So there is a measure which kind of measures that, which is called betweenness centrality. And the way it measures it, there is a formula, of course, but the way it measures it, like intuitively, you could say that basically we look at all the shortest, connections from node A to node B for every pair of nodes. So basically we look at how does Vasily connect to Kate? How does Fyodor connect to Dmitry? How does Alex connect to Daniil? So we look at all those connections and see basically how many of those connections go through this node. And then we do the same for each node. So how many of those connections go through Katerina? How many of those connections go through Vasily? And then suddenly we see that Alexei is much more important. So basically that's how we formalize it. So here you have a real visualization of real calculation of betweenness centrality made actually in Gephi, which visualizes that. And you can see Alexei is like the biggest one. So he has the biggest value of betweenness centrality because he has the biggest number of those connections flowing through him. So he's this kind of hub through which the flow of this connectivity goes. Some people speak about flow of information if we're talking about social networks, but it doesn't have to be information per se. It could be a network of something else, of network of trade, of electricity, or whatever. Important thing is we can measure like how important is he for the overall connectivity of the network. And there are many more centralities which reflect different, the specificity of node's position in network. There is a closeness centrality. There is the eigenvector centrality, which is kind of something in between degree and betweenness, I would say. And there are many other. So this is one thing that basically gives you a formal tool to actually try to differentiate your actors in your network according to how important they are for the network structure. And this is something that we use in literary scholarship as well. And this is something that historians, for instance, use in history scholarship. I will mention one example like this. And the second reason, which I like, is the all sorts of approaches to community detection and like generally, studying the overall structure of a network, because a network, although it's such a simple model, just a set of nodes connected by by edges, could have very different structures which reveal certain features of the system you are studying. We already saw that on my example. So we saw that you basically figured out just by looking at the network that I have 3 big groups in my social network. And this can be done to other objects of research as well. So network structures can vary, and even if you have like similar number of nodes and similar number of edges, like in this paper, which is a classical networks paper from Nature Journal by Watson Strogat. In this paper, so they give you example of 3 networks which have identical number of nodes, an identical number of edges, and yet you can see they're very different. So there's this one regular network, which is basically a very kind of fixed pattern thingy. So it like each node just has like regularly 4 connections to a very predictable number of nodes. And then you have a different type of network, which is called small world, which I will speak about a bit later. And then you have a completely random network, where basically the nodes are just randomly assigned 4 connections to some other 4 nodes. And these networks differ very much in their structure, and there are measures to capture that difference. And there are many objects in real life which, for instance, exhibit the features of this kind of network in the middle of the small world one, and this is actually quite helpful in certain research. Here's a textbook example for you of communities detection from social network analysis from the history of anthropology, basically. The famous karate club, which is a case from the 70s where an anthropologist was studying a small karate club in an unknown or unnamed, in the paper at least, American town, where people communicated outside of the club. Basically, they fried barbecues together outside of the training. And he was lucky enough that the club basically broke up in the middle of his study when he was, busy recording how they interact between each other. And half of the members split and sided with the instructor who wanted to race, basically. And half of the people did not split and stayed loyal to the club management, which didn't want to give a raise to the instructor. And so basically they split up into 2 clubs. Since this guy had information about like who was talking to whom before the split, so he thought, okay, could I use this model, this network, which I have already, of informal connections? Could I use this to actually predict this split, the schism of this club? And he wrote a program which basically, based on the data collected by him, tried to predict the boundaries of this group split. And we can still do that, by the way. So his program did relatively well. And we can also do that. So this karate club dataset is one of the most well-known datasets in the history in the network analysis. You can always find it on the internet and download it in multiple formats. And we'll speak about formats later. So here's my visualization, for instance, made in Gephi. And here you can see the titles of the nodes. So this Mr. He's or officers. This is the ground truth, basically. This is what we know about the split, like who stayed with the sensei, with the master with the instructor. They are Mr. He's. And who stayed loyal to the club's management. They are the officers. And with the color, you can see that the color does not exactly match these labels, and that's a feature. That's how it should be, because the colors are actually a result of automatic clustering, which I did in Gephi using the modularity clustering algorithm, which is built in. And you can see that although it's not predicting perfectly, but it's predicting the split pretty well. So based on the structure of the network, who spoke to whom and who didn't speak to whom, you can infer to a large extent the split which happened in real life, and that's why this case is so important for us. That's why we like this case, because it actually shows that network data can be useful and can reflect real properties of real systems in real life. But you might ask, okay, that's all very nice, but that's social science, and I'm doing humanities. So how does this relate? How did this come to the humanities? Actually, from social sciences, of course. So network analysis has a long tradition in social sciences. Already about 100 years ago, there was this psychologist and psychotherapist, I would call him, Jacob Morena, who did study social networks of school kids, and that's a very interesting study. I just like it, even though it's very crude, and made with a pencil and paper, basically. So in his study, he basically recorded who wanted to sit with whom in school classes of different age. And so what he shows is basically if you take like early classes, like first grade, second grade, you have this one particular popular girl normally, and everybody, boys and girls, want to sit with this particular popular girl. And here I think the round shapes are girls and the triangle shapes are boys. But as you go further, if you start recording like the same preferences in the older groups, like third grade and fourth grade, then you start seeing some sort of separation again, like in Karate Club. So basically you start seeing that boys start wanting to sit with like their boyfriends and girls want to sit with their girlfriends, and there is almost none of this kind of There is almost no desires of boys sitting with girls or girls sitting with boys. The typical kind of school dynamics when boys just hate girls or despise them at least. There's this kind of moment, pre-puberty kind of hostility, let's say. But then and then this separation hits the maximum in Morena's case. In Morena's experiment, it hits maximum at the 6th grade, where people only have formed this kind of formations within their gender groups, and basically the network gets separated into several totally independent components, at least in this particular work. I don't know if it's representative or not, but that's what Morena showed. But then puberty hits, of course, and then all of a sudden, boys discover interest in girls and girls discover interest in boys, and then they want to sit with each other again. But there is no, again, at this point, there is no one particular popular girl, but many girls are popular. So you see this kind of convergence back to everybody wanting to sit with everybody. So this is an interesting case, I think, which shows kind of that already 100 years ago, network analysis was already being applied to objects of research which concerned humans and human behavior and human psychology, which is of course already not so far away from humanities. And of course, there was a lot more research done in the second half of the 20th century. So Karate Club I already mentioned. There was a paper in 1976. You can read it, and it actually has networks in there, so you can look at them. You can look at the data which Wayne Zachary recorded in the form of the matrix, basically who spoke to whom. So the rows and columns are basically members of the club. And on the intersection, you get either 0 or 1 if they spoke or not. And you have even a crude visualization of the network. And there was also a paper, a very influential paper by Mark Granovetter in the American Journal of Sociology, from which the expression, the strength of weak ties actually goes. That's the paper which gave birth to this concept of the weak ties, which are sometimes more helpful than strong ties. And what Mark Granovetter did is he actually studied the Italian community of Italian immigrants in one particular American city. And basically he studied how they acquire jobs, how they find jobs. And he found out that it's normally done not through immediate connection, not through immediate kind of, closest family connections, but through remote connections. And he used networks to model that. And in the early 90s and in the 90s and early 2000s, social scientists actually started trying it on the objects of research typical of the humanities. So it was actually, at least as far as I could, study, and I studied, history of social network analysis. It was social scholars first who started applying a network theory to objects of historical and literary research. So the cases I know of, and you might know others, so please let me know. In 1993, there was a couple of social scholars. For instance, Padgett is a politologist. So he's more like a political scholar even. So they applied network analysis to the data on the Medici family and other Florentine families to study basically how they formed alliances and profited from this. And then there was this paper from 1998, which to my knowledge is the first kind of serious attempt at literary network analysis. And again, it is done by in this case, 2 German anthropologists who already were familiar with the concept of network analysis from their anthropological studies, of course. And then they chose to apply this to a literary work, in this case, a novel, a contemporary novel, Simple Stories by Ingo Schulz. And it's a novel with a very complicated structure of characters. And they basically try to make sense in how characters relate to each other and how they interact, and do they cluster in certain meaningful groups by modeling them as networks. And there was this steady stream of social scholars writing papers in journals, in journals on sociology and anthropology. Like again, the American Journal of Sociology was several times the venue where they published, or like Human Nature, for instance, where they tried to basically take their methods and apply it to humanistic objects of research. Like in this case, they tried this concept of small world networks, which are basically networks in which you have not that many connections, but the structure of the network is so that everybody is reachable to everybody in a very short number of steps. That's the feature of small world networks, and it can be formalized, of course. But the important thing is that this concept existed and was created in the social sciences and then applied to Shakespeare and to check if Shakespeare's plays actually exhibit the same features, even though they are not, of course, the product of natural or social system. And this went on, and there were some large-scale attempts like this case where scholars, and in this case actually physicists, applied network analysis to study tens of thousands of Marvel comic books and to figure out how the networks of superheroes are constructed, and they came up to some pretty interesting conclusion about how superheroes are we're very well connected, and villains are not. Basically, that's what you get from their research. But the problem was that the actual humanities scholars were all this time almost missing. So it was all done, without awareness of what's important for the humanists. It was all done by, social scientists, coming into this domain of humanities with their methods, but lacking the understanding of what humanities are doing. And one of the earliest people who actually brought network analysis to the humanities from the humanities perspective was Franco Moretti in let's say early 2000s and 2010s. He wrote this paper, which then became part of his distant reading book, Network Theory Plot Analysis, where he basically applied network analysis to the study of literature. And this is how Moretti advocates the use of networks. So he basically says they make visible certain regions within the plot, and he showcases it using Hamlet. So his claim is basically that he found a zone of death in Hamlet, which is a bit too far-fetched, and also like this, the whole idea that networks represent a plot of a play. I would say it was disproved later when we started studying networks of plays on a larger scale and started looking at thousands of plays. So it doesn't seem so, but there are definitely certain interesting features of plays which networks do capture. If you construct a network of a social network of play, of who speaks to whom basically in a play. So networks as a reduced model for plot that makes certain key features of a play more visible. That was the Moretti's claim, which I wouldn't say exactly was fulfilled, but still the main direction in which he thought, I think, was right, because he said, yeah, okay, we are doing here great reduction and great abstraction. We are compressing basically 4 hours of stage time, which usually takes Hamlet, to just a very abstract mathematical thingy with edges and nodes. So we are studying Hamlet without reading a single line of Hamlet. That's what Moretti shockingly said back then. But just like X-ray, which reduces a lot but also lets you see hidden things, you also see certain hidden things which you weren't able to notice as clearly when you were just reading the play. That was his claim, and I think that's a methodologically maybe a good stance, let's say, because that's why we need models in science. That's why we need models in scholarship, to reduce a bit of complexity and then single out something which is not visible without the model, which should be simplified to be viewed basically. And today, literary network analysis and humanistic network analysis is a big thing. This idea caught some fire in the literary scholarship community, and we are doing network analysis on a large scale, for instance, in Dracor project. And you can do both. You can, on one hand, you can just model your data as networks and just look at it. And as you already seen, again with my social network, this already gives you something. This already gives you some interesting insights sometimes. So for instance, here you see a certain part of the German drama corpus, which you have in Dracor. And even before we start any kind of formal analysis, you see this play in the center, which is Schnitzler's plays, which is called La Ronde, or like round dance, basically, if you could translate it to English like this. And you can see it's structured as a round dance, basically. And if you start reading it, you figure out why, because it's basically a hotel room in which like one man meets one woman, then the man leaves, and then another man comes, and then the woman leaves, and then another woman comes. So it's always this kind of dialogue, but always one character leaves, and then another appears. And then they never speak in trio, but they always speak in twos. And that's interesting that basically he wanted to do this to play with this form, and you can see it in the network. Or you can see interesting development in the German drama in the late 18th century. If you look at this part of the German drama history in the form of networks, you can see here in the center a play by Goethe, which is called Götz von Berlichingen, or The Knight with Iron Hand. And it's a play which is written basically in Shakespearean style. So it's a historical play, and it basically forsakes all the conventions of classical theater in favor of Shakespeare. So it doesn't take place in one place, it doesn't take place in one time. It's a historical play which features different locations and and battles and castles and movements of armies. And you can see it in the network. You can see how different it is from the networks that come before it in the German drama. You can see that you can see it's polycentric basically. You can see it doesn't have this kind of one single center of one single blob of main characters which are all talking to each other all the time. And this is something you can formalize. And this Goethe-Shakespeare structural parallelism, you can even see it if you just plot together some Shakespeare's historical plays. In this case, I chose Henry VIII and put it together to Götz von Berlichingen, and you can see they're kind of similar in their structure, in their polycentric kind of structure with multiple clusters. And what's nice about this, and what I like about this, is that this process can actually be traced in other literature. So you can, for instance, go into Russian literature and look, okay, do we have similar kind of development at some point? And it turns out we do, at least on the current Dracor data. We can say that the first play, which looks like this, which is polycentric, which has this kind of same features, is Boris Godunov by Pushkin, which is a very important play for the Russian drama in general. And it looks like this, and it's actually, the reason for this is same as Goethe. So Pushkin read too much Shakespeare at some point. And we know this because he said it himself, basically. So I will now quote you some excerpts from Pushkin's personal writings, basically. And here above, it's in Russian, but I translated it for you into English. And you can see he's writing, unaffected by any other literary influence, I was following Shakespeare in his free and broad depiction of character, in his careless and simple construction of settings. That's what he writes about Boris Godunov. And then he says that, yeah, our theater needs reformation, basically. So I laid out my tragedy according to the system of our father Shakespeare and sacrificed two of the three classical unities and barely managed to preserve the third. So that's what he says. And you can also see that especially well if you compare the historical play, Shakespearean play by Pushkin, to a classicist play which was written on the same topic. So like the historical plot which they are dealing with here is roughly the same. It's this kind of very important period in Russian history when the dynasties were changing and there was a lot of trouble between that. And on the left, you can see the structure of the play, which is written about that same period, but by a typical classicist playwright, Sumarokov. And he wrote this 50 years before Pushkin. And you can see how different the structure is. And can we make it more formal is the question, right? I mean, looking at it is nice, but can we actually come up with some number which will reflect this difference? And there are many numbers you can come up with, and some of them are more complicated. I'll just give you one of the most simpler ones. I will give you the parameter which is called network density, because density is really a very simple and understandable concept in the networks. You can always measure density. You can even count it yourself, by hand, because density is just a relation of the number of edges that you have in your network to the total number of edges that you could have given the number of nodes. Like for instance, here you have 4 nodes, 4 actors in this network, and the maximum number of edges you can have is 6, because if you connect everybody to everybody, then you'll have 6. Exactly 6 edges. And on the left, you can see a network which has like density of 50% basically, where you just have 3 connections out of 6. And on the right, you see the maximum density. The density is always between 0 and 1 basically. And if you measure density here, you will see that for classical plays, it's always high because you have always have this small number of characters who always talk to each other, and there is not so much, not so much clustering, and so the density will always be high. Whereas for the historical play written in the style of Shakespeare, you will have this kind of separate clusters, sometimes not connected to the whole thing when you have just these scenes in the battlefield with some random people are talking. And then you will have your density really low. So in this case, it's 0.11, so just 11%. So that's one of the formal measures, formal ways to capture that difference, which we see in the form and measure it. And you can actually double check it yourself. All this data is available in Dracor. You can get the network data, you can get the density measures already calculated for you. So that's one thing that's helpful. We can also zoom in a little deeper to the level of individual actors in our networks. And in literature, it could be used to differentiate characters. In history, it could also be used to differentiate actors. If we get back to Moretti for a second, so he uses, for instance, this network model to speak about the role of Horatio in Hamlet. And he claims that he never fully understood the role of Horatio until he looked at the network structure. And basically what he does is he tries to remove Horatio from the network and see what happens. And then he compares it to what happens if he removes other characters one by one, basically. So what happens if you remove Hamlet? What happens if you remove Claudius? What happens if you remove, I don't know, Fortinbras, and so on. And what Moretti concludes is basically if you remove Horatio, basically the network disintegrates into two totally different networks: the court in Hamlet and the rest, basically all these great graveyards and outskirts and Norwegians and stuff. And that doesn't happen if you remove Claudius. And that's interesting because in terms of degree, if you just count the number of connections, Horatio is less central than Claudius. So he speaks to less number of people in Hamlet, but he's apparently more important in terms of like interconnectedness. And Moretti doesn't use betweenness, but we can do that for him. We can check his assumptions by measuring degree and betweenness. And if we do that, we see that indeed the general reasoning is correct. So Claudius has a higher degree, so higher number of connections than Horatio, but Horatio has a higher betweenness in Hamlet. And that signifies his kind of unique position as this kind of intermediary character in Hamlet. And that's what Moretti claims, basically, by just looking at the network and removing nodes, but we can do it even without removing nodes, just by measuring centralities. And now, for the last time, we go back to Pushkin, because this play by Pushkin, which I really like, so I always show it, it has a character which is also possesses the same characteristics as Horatio, which incidentally has the same surname as the author. So the character is called Gavrila Pushkin. And the thing about him is that if you read the play, he doesn't seem very important at first. He's just like little sidekick of the Lжедмитрий, of the Samozvanets, who is the imposter who basically goes to claim the Moscow throne and in the end, defeats Boris Godunov and becomes the new Tsar in Moscow. And this Gavrila is like not very important it doesn't seem extremely important if you read the play. But then if you kind of look at his betweenness, he's really like the top character by betweenness, although he doesn't have the highest degree. And if you then reread the play after that, you figure out that indeed he's this kind of the shadowy figure which kind of is a hidden mover of things. So he's the person who basically goes between Moscow and Poland all the time to try to diplomatically settle, the conflict between the imposter and the old Tsar for the throne. And then when it doesn't work, he's the one who goes to the military leader of the Boris and convinces him to change sides, basically, and thus ensuring the victory of the other guy. And at the end, he's the one who goes to the folk, to the people, and reads out the orders of the new ruler. And the folk here is this blue third kind of cluster, which is a character of its own, but also like separate from both the Moscow Kremlin basically and the imposter in Poland. Yeah, and so you can see that the structure of this play and the unique position of this character shows something, and it's especially visible if you publish it as a network. And this is something that also aligns with Pushkin's own, personal mythology, because in his poetry he also wrote about how Pushkins were like the people who were like the actors in Russian history. So I think this basically an Easter egg laid by the poet and discovered by the network analysis, because I haven't seen any work by Pushkinis who would speak about this very clearly. Maybe I missed something. Of course, I haven't read all of the stuff which is written on that topic, so maybe I missed something. But I really like this story because I think it digs up something new in the literature and shows it quite clearly. And what's also good about this approach is that now that we have a formalization of this type of character, so basically somebody who has a uh, who has a who has a high betweenness, but not so very high degree. So that's kind of unique combination of centralities, which is not always the case, because in many cases just the protagonist would have both high betweenness and high degree. And that's what happens to Hamlet, and that's not something that's very interesting. But if you get this character which has this kind of imbalance in these two measures of betweenness, then you might look at them, you might even extract all of them automatically if you have networks, and then look for them in other places where you haven't seen them before. And when we did that on Russian corpus, at least, we came up with a selection of pretty interesting characters, I would say. So we came up with this guy called Bitigovsky in a play called The Death of Ivan the Terrible by Alexei Tolstoy. And this Bitigovsky guy is actually he is actually a double agent. So he's somebody who first spies on one of the main characters of this play, on Boris Godunov again, actually, and then he's kind of he's basically blackmailed into changing sides, and then he starts spying on the people who first hired him to spy on the Boris Godunov. So he's a double agent, classical double agent. Or you get this person whose name is Kalachnik, so basically, bread seller, you could call him, in the play Dmitry the Impostor by Alexei Ostrovsky. And he's kind of a spy as well, and also a whistleblower. He's kind of like somebody who acts as who calls the shit out loud. Basically, he's that kind of character who tries to be the voice of the people and to highlight some shady activities. And what I also like, and this is maybe a shout out to those of you who are not literary scholars, because I can imagine there are also some historians here who might be a bit tired by now by all my literary examples. So actually, this method of looking for the discrepancy between the betweenness and the degree has been used also by historians. There is this wonderful paper by Ruth Anert and Sebastian Anert in History Workshop Journal, which is called Metadata Surveillance in the Tudor State, which opens with a brilliant epigraph from the NSA director, which goes, "We kill people based on metadata," and then they try to figure out certain real spies in the correspondence of the British Tudor epoch, basically. So they take data from the so-called government papers, I think it's called in Britain, and then they build a network of correspondence of like more than 20,000 correspondents, more than 1,000 connections. And then they look for people who have high betweenness and low degree, and they find some pretty interesting people, like this guy called John Snowden. Incidentally, he's also called John Snowden, just like the other Snowden. But he lived in much earlier, and he was actually apparently also a double agent. So he was like a spy for the Catholics in England, but also he apparently worked for the English crown and spied on Catholics on the continent. So this is an interesting case, I think, and this kind of concludes my introductory rant about literary network analysis and the explanation of why we should care, and what will follow next will be like much more practical and much more hands-on and applied. but I will just, sum it up. So there are at least two ways to do network analysis of a research object. One is more large scale, when you just have multiple networks and then you investigate their kind of high-level properties. So do they have high or small density? What about do they have this feature of being small world networks? So does the rule of six, handshakes, 6 degrees of separation work in there? Do they have some peculiar structure, or are they completely random? So all this can be, measured. All this can be visualized during different layout algorithm. We'll speak about that a bit later. So that's one approach. Another approach would be a smaller scale approach, when you have some individual network or just one or two networks, for instance, of a literary work, of a historical source, of something else, a social network, some network you just constructed from your own observation. And then you look at this particular network specifically for like what are the positions of individual nodes in there. Who has the biggest between centrality? Who has the biggest degree? Is it the same person or the same actor or different? And that will also give you some interesting information about how does this network function and what are the important nodes. And both ways actually provide you with formalization and numbers. So both ways are, I wouldn't say objective, because I don't believe in objectivity in this case, right? But because it all depends on how you create a network. But it will at least give you some, reproducible model with numbers. So something you can always count, and it will always, count. In the same network, you will always have the same number of, same number of density, basically, same number of nodes, and so on. So you can measure those structural metrics like density, as I mentioned, but there are more complicated metrics like small worldness, like clustering coefficient, like diameter, which is basically the length of the longest path between two nodes. And there is the centralities, which are more like character based. You can also look at the clustering at the individual level. So this is the end of this kind of theoretical part of today's workshop.